Imagine a programming language that looks like a painter's palette. Instead of lines of text, you see vibrant squares of color. This is the Pantone Visual Programming Language, or P-VPL. It's a revolutionary way to code, using the familiar language of color to create everything from simple animations to complex algorithms. In P-VPL, each Pantone color swatch is a command, a variable, or a logic function. Think of it like building with Legos, but instead of bricks, you're snapping together blocks of color. The result? Coding that feels intuitive, engaging, and surprisingly beautiful. P-VPL opens up a world where anyone can learn to code, regardless of their background or experience. It's coding for visual thinkers, artists, and anyone who's ever looked at lines of code and felt intimidated. So, are you ready to trade your keyboard for a color wheel and embark on a journey into the colorful world of P-VPL? Let's dive in. You might know Pantone from the world of design and print. They're famous for their standardized color matching system, those iconic little swatch books graphic designers and printers rely on to ensure colors are consistent across different mediums. Now, imagine harnessing that power of precise color communication for programming. That's what makes P-VPL so ingenious. Each unique Pantone color, with its specific hue and saturation, represents a distinct coding element. For example, a vibrant classic blue might initiate a loop, while a soothing pale dogwood could signify a conditional statement. These colors aren't just arbitrary, they're carefully chosen to intuitively reflect their function. This visual approach makes P-VPL incredibly accessible. Instead of memorizing complex syntax, you're learning a new visual vocabulary. It's like learning to read a map where mountains are green and oceans are blue, intuitive and engaging. P-VPL uses a grid system to organize your code. Think of it like a digital canvas divided into cells. Each cell can hold one Pantone color swatch, representing a specific command or value. The arrangement of these swatches on the grid dictates the flow of your program. You place swatches next to each other to create sequences of actions, just like arranging words in a sentence. But here's where it gets really interesting. P-VPL leverages the concept of recursion. Remember those Russian nesting dolls that fit inside each other? Similarly, in P-VPL, you can embed entire grids of code within individual cells. This means you can create complex, multi-layered programs by nesting blocks of color within each other. It's like having a whole symphony orchestra playing within a single note. Let's see P-VPL in action. Imagine you want to make a light blink. In traditional code, this might involve several lines of text. But in P-VPL, it's as simple as placing two color swatches next to each other. Illuminating yellow, which represents the on state of the light, and jet black, representing the off state. Repeat these two swatches in a sequence and voila, your light blinks. Now let's get a bit fancier. Imagine you want to create a pattern of spiraling squares. In P-VPL, you'd use a combination of color swatches representing commands like draw a square, rotate, and change size. By nesting these commands within a recursive loop, you can effortlessly generate intricate and mesmerizing patterns. One of the most groundbreaking aspects of P-VPL is its ability to incorporate emotional context into code. Remember how each Pantone color has a unique emotional resonance? P-VPL leverages this by allowing for color overlays. Imagine you're programming a chatbot. By overlaying a block of code with a wash of Serenity Blue, you could signal that the chatbot should respond with a calm and reassuring tone. This fusion of color and code opens up exciting possibilities for developing AI with emotional intelligence. Imagine robots that can not only understand but also respond to human emotions, creating more intuitive and empathetic interactions. The potential applications of P-VPL are as diverse as the color spectrum itself. In education, P-VPL could revolutionize how we teach coding to children, making it as intuitive as playing with building blocks. In art and design, imagine artists using P-VPL to create generative art, where algorithms and color palettes collide to produce stunning visuals. For emotional AI, as mentioned earlier, P-VPL's color overlay system could be instrumental in developing AI systems that can understand and respond to emotions. And in sacred technology, P-VPL could be used to create interactive rituals and ceremonies, where color sequences evoke specific feelings and intentions. The possibilities are truly limitless. P-VPL represents a paradigm shift in how we think about programming. It breaks down the barriers between logic and creativity, between instruction and intention. By using color as its language, P-VPL taps into a universal form of communication that transcends cultural and linguistic differences. It reminds us that code, at its core, is just another form of expression, a way to translate our thoughts and ideas into reality. As we continue to explore the vast potential of P-VPL, one thing is certain: the future of coding is bright, and it's bursting with color.